Hi, hello everyone. A very good evening to all of you. Yeah, all good. Yeah. First of all, I would like to briefly introduce to myself. My name is Imdadul. I'm from Assam. I have done my post graduation in chemistry from National Institute of Technology, Tiruchirappalli, which is situated in Tamil Nadu. Yeah, basically, I'm a chemistry faculty of NEET and JEE aspirants having 2 year experience in this field. Okay, so today I'm going to discuss a very basic organic that is called GOC, which is the fundamental concept to understanding the entire organic chemistry. Is as you know, organic actually chemistry is studied under some branches, right? Okay, these are like inorganic chemistry, physical chemistry, and organic chemistry, and analytical chemistry, right? So to understanding the organic chemistry, the basic requirement is that you have to first know the GOC concept, right? So today I'm going to discuss the GOC, that is called general organic chemistry. GOC stands for general organic chemistry. General organic chemistry. Yeah. So, students, um, in chemical reactions, first of all, what do I mean by chemical reactions actually? Chemical reactions is the reaction in which old one broken, new one formed. The whole process is called chemical reactions, right? So, if I'm taking one example, simple examples, like if I'm generalized the chemical reactions, what will be happened actually there? Reactants will be there, right? Reactants. Okay, that reactants react with reagent in the presence of some temperatures, some pressures, depending on the type of reactions and and all. Here, some conditions are used here. This may be temperatures, this may be low temperatures, this may be high temperatures, right? Okay, so here the reagent and the reactant, okay, react with each other. This will form first intermediates. What is it? Intermediate. This intermediate actually may be classified as carbocation, carbanion, free radical, okay, benzene, nitrene, and etc. Okay, now come to the point. Actually, what happens when reactants and reagents are react with each other, it doesn't directly form the product, it will form first intermediates. Okay, depending on the stability of intermediates, the percentage of the product yield is depends actually. So we are going to discuss here. See, depending on the stability of intermediate, yeah, you can easily identify that in a given reactions which one will form the major product and which one is the minor product. For that one, you have to know the concept of GOC. Okay, so here I'm going to okay, after formations of intermediates, it will form the products and byproducts. Products plus byproducts. Okay, products plus byproducts. Now here, what is reactants and what is reagent? This reagent may be act as nucleophile. What mean by nucleophile? You will get to know after some time that nucleophile is the species, that means which are electron rich, right? And electrophile, which is represented by E plus. If the reagent is nucleophile, of course, the reactant will be electrophile. Okay, and vice versa. Okay, so now I'm going to discuss the things that is called homolytic bond cleavage actually, or bond bond fission, or you can say cleavage. Okay, bond fission or cleavage. Okay, See, this happened in two ways. Okay, in two ways. One is called homolytic cleavage. Homolytic cleavage. Another one is heterolytic cleavage. Heterolytic cleavage. Okay. For example, what is homolytic cleavage? See, homolytic cleavage means the shared pair of electrons are equally distributed among the elements wherever bond is formed actually. See, for example, if I am taking example, suppose carbon formed bond with A, which is an element. I'm not going to specify that one. And carbon valency is 4, supposed to be this type of compound is there. Then here it's a covalent bond, right? That means in one bond 2 electrons are shared actually, overlap 2 electrons here, right? Okay, forming the 1 sigma bonds. If the bond is breaking like that, suppose the shared pair of electrons are breaking in such a way that the electrons are redistributed among them, and it will form like this, here and here. This type of intermediate is called free radicals. Okay. And in case of homolytic cleavage, what is it actually supposed to be? If I'm taking the same example here, that is A plus, okay, some reaction conditions will be there. I'm not going to discuss that now. Okay, so basically you have to know the meaning here. Okay, so here if the bond is cleavage in this way that the shared pair of electrons are occupy or varying only one atom, it will form like this, minus and A plus, or vice versa, right? Or you can say this is formed in this way also, right? It is plus, it is minus. So basically here carbocation is formed. Carbocation is formed. Carbocation means electron deficient one. Okay, you will get to know these things, don't worry. Now I'm going to discuss the most important part, that is called electronic displacement effect, right? Electronic displacement effect, which is very much important actually. Electronic displacement effect. Okay. Electronic displacement effect again categorized into two types. One is called permanent effect. Permanent effect. Another one is called temporary effect. Okay, temporary effect. What is permanent effect? That means permanent effect are those effects which are present or always operate. Okay, always operate in the molecule. Okay, always operate. That may be inductive effect, hyperconjugation, resonance, and mesomeric effect. And what is temporary effect? Temporary effect means with the presence of some reagents or some electrophiles, the reactants will get polarized. In the presence of some things, if the if any electronic displacement effect will be happen, that is called temporary effect. Okay, you will get to know. Okay, so first of all I'm going to discuss the permanent effect. What is permanent effect? Permanent effect means which is always operate in the molecule, whether it will react or not, always present. Okay, now the first example of permanent effect is, that is called, I'm going to discuss inductive effect. Okay, inductive effect. So the question is that where this effect is applied, and what is called actually inductive effect in a. Okay, so actually you have to remember some points here. That is, the first one is it operates to sigma bond. It operate to sigma bond. Okay, it operates to sigma bond. Second thing, that partial charge development. Here, due to this effect, in molecules partial charge is developed, and it is due to the electronegativity difference between them. Okay, so what is it? Partial charge development will be there, development. Okay, development will be there. Okay, the third point is this effect can be neglected, after third carbon. And fourth one is very much important, fourth one is it is distance dependence effect. That means it will distance dependent. Okay, distance dependent. Okay, now what is this? I will explain with the taking the appropriate examples. Suppose if I am telling you students that supposed to be, if I am taking one example, supposed to be ethane, CH3. Tell me one thing, this bond is polar or non-polar? This bond is polar or non-polar? Obviously, here the electronegativity difference is 0. Obviously, this bond is non-polar one, right? This bond is non-polar. Okay, fine. Now, I am giving another example. Suppose here number 2, that is CH3, CH2, and supposed to be it is Cl. Now tell me one thing, that these bonds are polar or non-polar? Yeah, think about it and tell me. Okay, listen here. Due to the electronegativity difference, the shared pair of electrons are closely lies to the where? On chlorine. Why? Because the chlorine is more electronegative element than carbon. So basically here the charge will be developed, that is called partial charge. So here it is positive and here it is double positive, you can tell, or here it is triple positive. Okay, that means here the bond is purely not polar. That is purely not non-polar. It's slightly polar. Why? Because the shared pair of electrons are attracted towards the chlorine, which is more electronegative element, right? So finally, this non-polar bond is become polar one due to here more electronegative element, that is called more electronegative element are attached here. Okay, so dear students, this effect, that means inductive effect, can be classified into two types. One is called plus I effect, another one is minus I effect, Okay, so what happened in plus I effect? Supposed to be here some carbon chain are there. I'm not going to balance that one. Suppose here G group is there. If the group nature is like that, they push the electron density towards the carbon-carbon single bond. That means here positive charge will generate, and here negative charge will generate, supposed to be 1, and here negative charge will be generate, it is 2, here negative charge will be generate 3. Then this G group is called plus I group, or you can call it electron donating group, okay, or electron releasing group, or it is electron releasing group. Okay, so here one thing important that that delta minus 1 is the greater than delta 2 minus, then delta 3 minus. As I told, this is the distance dependent phenomenon, right? So here if the distance is increases, that means the effect of this phenomenon will be decreases. Okay, so in case of minus I effect, what will happen? Supposed to be here carbon group is there, supposed to be G group is there, and these group, if the nature of the group is electron withdrawing one, that means the shared pair of electrons basically attract by towards itself, right, by itself. So here it will generate the minus negative charge, and here it will suppose plus 1, and here suppose plus 2, and here suppose plus 3. Okay, so obviously the magnitude of plus sign 1 is greater than the magnitude of plus 2, then magnitude of plus 3. Okay, so this group is basically called minus I group. What is it? Minus I group, or electron withdrawing group. Okay, electron withdrawing group. Okay, now here you have to remember some series. Here you have to remember some series that is called power series, that is called minus I series with power. I'm writing here minus I series with power. Okay, with power. Yeah, some mnemonic techniques are there. With the help of that one, you can easily remember that one. I'm not going to discuss that one. I remembered in this way using the some mnemonic techniques. Suppose here the first power group is NF3 plus, then NR3 plus, then SR2 plus, then NS3 plus, then NO2, then SO3H, then CN, then HCO, then COOH, then fluorine, chlorine, bromine, iodine, OR, OH, and C triple bond H and NH2. This is the group. Basically you have to remember that one. And here also I'm writing the plus I group or series. Okay, and here the first is CH2, then NH, then O minus, then CO minus, then 3 degree alkyl, then 2 degree, then 1 degree, then CH3 methyl group. Okay, and you have to remember one more thing here, that is the isotopes of hydrogen. Tritium will found more showing the plus I effect, then deuterium, then hydrogen. Okay, now it is time to study their applications. Why we need to know which group is showing the plus I effect and plus minus I effect, although the effect is as compared to the other effect like hyperconjugation and resonance, we will give the least priority about this one, but it is very important to knowing which one show the plus I effect, which one is the showing the minus I effect, and a lot of applications are there. I'm going to discuss one by one. So applications of inductive effect. Basically I'm going to do applications of inductive effect. Application of inductive effect. Okay, the first application is to compare acidic strength, of carboxylic acids, and alcohols. Okay, and alcohols. For example, if I'm taking one example, that is carboxylate ion, that is COOH, right? COOH it's a very weak acid, and equilibrium is formed here basically. So here it will form conjugate base and acid, right? Now, you know like it is called, conjugate base, conjugate base, okay. And listen, if the conjugate base is very much stable, that means these negative charge will stabilize, right? That means it can easily lose the protons. And as we know, according to Bronsted theory, that means which donates the proton, which donate the protons, that will be the species which will easily donates its proton, it will be the acid, right? So that means here it's a good acid. If the stability of the conjugate base will increase, from here you can write one note over here, that is stability of anion, stability of anion, that is called conjugate base, is directly proportional to acidic strength of COOH. Oh my god, it's a very much important point, I'm telling you. Hello, listen. The acidic strength is directly proportional to the acidic strength is directly proportional to the acidic strength is directly proportional to stability of stability of conjugate base or anion. Now, from now on onwards, you have to remember one thing. What is this? See here, I left one valency of carbon, right? Why is it so? Here, if CO group is there, now if in this valency minus I group, how would you identify that which one is minus I group? See here, I'm explaining this one, minus I series, that's why, right? If it is present here, that means it is good things, which will stabilize this negative charge, that will stabilize, because from here, if you open this structure, that means this one is this and this one, resonance is there, but still additional support is there to reduce the electron density on oxygen, right? So stability will increase, and it is the acidic nature or acidic strength of the corresponding acids will increase. So if in these valencies of carboxylic acids, if it is plus I effect, then it's a bad things for their acidic strength, it's a bad things. Why? Because supposed to be here, if this one is the carboxylate ion, right? If it is resonance here, right? Now if plus I group is there, they push their electron density towards the here, and the electron density among oxygen will increase, that won't allow to lose its proton actually. So that's why plus I effect is very bad things. So from here you can generalize one thing here, that is acidic strength directly proportional to minus I effect, inversely proportional to plus I effect, okay. Give me 1 minute time. What is it? Yeah, acidic strength directly proportional to minus I, inversely proportional to plus I effect. And the most fundamental things, most important thing is that, most important, I'm telling you, say, most important thing is that is called, it follows the DNP rule. That means D means distance, N means number. First you have to check out the distance, then number, then power. What is power? How would you identify which one will have more power and which one will have lower power? That's why I gave already the sequence of minus I series and plus I series, right? Basically you have to remember all the things, okay. Now listen, for example, if I'm asking question, that is, if I'm asking question, compare the acidic strength, compare the acidic strength of the following compounds. The number one is suppose CH3 COOH, and here CD3 COOH, and here CD3 COOH. Which one will have more acidic strength? Supposed to be here it is 1, here it is 2, here it is 3. Basically you have to check it out here. This one, this group, CH3 CD3 CD3. As you know that I told already that plus I series, right? Tetrem is more than D than H. So here first see, number is same, distance is same. Now number is also same, right? Now you have to check it out power, right? So here plus I power, the plus I power of CT3 will be maximum, then that means TDH. So the stability of acidic strength will be 1, then 2, then 3, because plus I effect decrease the stability of conjugate base. If stability of conjugate base will decrease, that means the acidic nature or acidic strength of the corresponding compounds will also be decrease. Okay, so here I'm giving one more example. That is, suppose here this one, here COH is there, in this way COH is there. Suppose here COH is there, and I'm going to attach, that is fluorine, that is fluorine, that is also a fluorine. Now tell me one thing, which one will have more acidic nature? That is 1, that is 2, that is 3. Now listen what I told. Plus I effect always follow the DNP rule, that is called distance, number and power. Okay, distance, number and power. Now listen, here from D the answer will come. See here distance, here it is here, and here the fluorine attached to it 2 carbon, and here fluorine attached to it the 3rd carbon. As I told, the plus I effect or minus I effect is a distance dependent one, right? So the acidic strength of first one is more, then second one, then third one. Very good, very simple, right? One more example. Suppose see here this one, like this COH, and here and here COH is there, and suppose in this one 2 chlorine will be attached here, and here NO group is there. Now which one will have more acidic in nature? Simple things, listen. Here see the distance on second carbon substituents are there, right? On second carbon substituents are there. Okay, yes. Now here D and P distance is same, then go to number. See here 1 NO2 group is there, here 2 substituents are there. Oh my god, listen what I told. Irrespective of the power, wherever the number is more, that will be more acidic strength, right? So that will be more acidic strength. So here second one will have more acidic strength than first one. Okay, here I'm giving one more example. Listen, so that your concept will be crystal clear. That is suppose D. Okay, suppose here this type of compound is there, and here this one is compound. Okay, here OH is there, and here O negative is there. Here the same is there, that is this one, right? Okay, so basically from here on second carbon substituents are there, right? So on the power, that means OR group are showing the more plus I effect, that is the plus I effect, right? And that is showing the minus I effect. Obviously minus I effect is good for acidic strength, so it will be more acidic. Okay, very much simple. Okay.